This is my lithium iron phosphate battery bank that I built, and it has 20 cells, and I connected 5 cells in parallel, then another 5 in parallel, then another 5 in parallel, and then the last 5 in parallel. So what that does is it creates 4 banks of 5. And if you connect them in parallel, the voltage stays the same. So each cell, each individual cell, is 3.2 volts nominal. And so when I connect all 5 in parallel, it's still 3.2 volts nominal, but it increases the amperage. So now I got 4 sets of 5. And so the red is the red bus bars that you see right across the front here. That just indicates that this is the positive side of the battery. And back at the other end, the black bus bars that have black shrink tube on them. And that's what this is. It's just shrink tube, black, red, and yellow. But that far one in the very back there, that is the negative terminal of the battery. So I have positive here, negative over there. The yellow ones connect now, each set of 5, there's 4 sets of 5, connects them in series. And so that's what bumps up the voltage. So the voltage of this battery is 12 volts. So it's a 12 volt battery for a 12 volt battery system in my boat. And I could have wired these differently to get 24 volts or 48 volts or 32 volts, but I decided to stick with 12 volts. The boat was originally set up with 12 volts, and there's a lot of accessories that you can buy that are 12 volts. Not as many 24 volts, and 48 or 32 is hard to find. And there's ways around that. But I decided to go ahead with 12 volts. My engine alternator charges at 12 volts, but the alternator on my engine really isn't set up for charging a battery bank this big, but I can add another alternator to the engine separate for this if I want. But eventually I'm going to be using solar panels and wind turbines to charge this. But I can also charge it with shore power, and that's what this gray box down here is for on the side. So that connects to the shore power outside on the dock, and that's how I've been charging it. So the thing about lithium batteries is that you don't want to overcharge them, and you don't want to over discharge them, especially over discharging, because if you go below, each cell is 3.2 volts nominal, and if you draw them down to 2.5 volts, below that, you're starting to risk damaging them. And if you go below 2 volts, you definitely damage them. So it's really important that you don't over discharge them. And so how I deal with that right now, the only thing I've been doing to make sure I don't damage this battery bank is I have a battery monitor here that monitors the voltage of each group of 5. So even though I got 5 cells connected, it's really like one big cell, one supercell. So there's 4 big supercells here. And that's the way I got it connected together. So that's 1 cell, that's 2 cells, that's 3 cells, that's 4 cells. And then when you connect the 4 cells in series, it becomes 12 volts. So, and that's what comes out the end here on the plus side, and the negative side on the other end down there is this 12 volt battery. So the only thing I've been doing to protect them is a battery monitor, and it's set to 2.82 volts right now. And so if any one of the supercells goes below 2.82 volts, an alarm goes off. And this thing has a very obnoxious loud alarm, which is good. That's what you want. So let's go back and we can see. This is each cell. So it's showing 4 cells. And right now, the first cell is at 3.287. The second cell is at 3.292. The third cell is at 3.292. And the fourth cell is at 3.297. So they're really close. Right now, this shows that they're within 10 millivolts of being balanced, meaning they're all the same. So they're only 10 millivolts out of balance, which is good, really good. Right now, they're only 29% charged, and the voltage is 13.17. So 12-volt battery will go between, 14 volts down to, can go down below 11 volts, but you don't want to go much lower than that when you discharge them. So this is the only thing I've been using to make sure that this battery bank does not get damaged. And so what I'm going to do now is I have installed a battery disconnect from Victron Corporation. And it's down here. I got it in place. So it's that blue box down there. And that's the battery disconnect. And how that works is I can program that to shut off when the overall voltage of the 12-volt battery goes down to a certain voltage. How I'm going to have it set is this battery alarm here will go off first when it gets down to, I got it right now set to 2.82. And I think this will be set to 2.81. So what will happen is, actually that's what it'll be set at. On the instructions, it'll be more like 12 point something, but, or excuse me, 11 point something. I can't remember off the top of my head. But at any rate, so what's going to happen is the alarm will go off first before this shuts down. So that way I'll know that it's getting close and it's going to shut down. Now, at that point, I can go ahead, if this alarm goes off first, then I can go ahead and start charging the battery before it shuts down. But if I'm not here, what will happen is this alarm will go off and I'm not here to hear it, and something keeps drawing the battery down, like I didn't shut something down. Usually I like to shut the whole system down when I leave. But in case I forget, then what will happen is that this battery disconnect down here will disconnect the battery from the electrical panel here. And on the DC side, that's all the red switches there. And then that way it'll save the battery from being damaged. So one little mistake, and you don't have no protection on your battery system, and it's real easy to get distracted or, go somewhere, have to go somewhere, be in a hurry, and you leave your battery system on and you have some lights on or something, and then one thing leads to another and you don't get back in time and the battery gets drained down. You can damage the battery to the point where all of these cells can be just thrown in the garbage, and they're not cheap. So that's what I'm going to do. I'm going to go ahead, and that'll be the last hoop I have to jump through for this battery system as far as protecting it, is just to make sure I get this battery disconnect connected in. So right now I got it wired in. It's not wired in yet, and then I got to program it. And so that's what I'm going to do. Okay, so I figured out what I need to do. So the red wire is the 12-volt positive side of the battery. It goes to the switch down here, the red switch right down here. And I'm going to leave it like it is. Now, on the other side of the switch, the terminal will go now to the to the battery protect, the Victron battery protect. So it'll go to the to that bolt on the right, that terminal on the right, and then from the terminal on the left, that will go into the panel, to this panel here. So on the DC side, which is where all the red switches are. And so, and that way, there's nothing between the battery and the switch to turn the battery off. There's nothing in between. I don't want anything that can fail. When I shut this off, I don't want any kind of fire hazard. And so that's going to be the safest way. So all I have to do is disconnect my panel, which is connected to the switch right now because this is not in the loop. And so what I need to do is connect a wire from the switch to the Victron battery protect, and then from the battery protect it'll connect into the panel, and that's how I need to wire it. So that's what I got to do. And so I'll go ahead and get started on the wiring here. Okay, I happen to have tinned copper wire, which is marine grade. I don't trust these crimped on connectors, these small ones. When you crimp onto a bigger cable, which I'm going to do this here in a minute, then those connectors usually ain't a problem. But I just want to make sure that is good. And I'll test it, do another continuity test just to make sure, which I'm sure, 100% sure that it's going to be good. Just going to turn this back on, probably shut off. No, it's on. Okay, let's see if I get a buzz. Yep, so it's good. And it's on tight. So yeah, I feel a lot better about this. Okay. Okay, so this is good. This is good. It's long enough now. So I feel safer now with this than that other connector. Okay, so this is done. Put it aside. Now I got to do, this is going to go from the battery switch to the in connector on the battery protect. So I'm going to be using, I think on one end, I could use this on both ends maybe. I'm going to try this on one end. Now I can't use this stripper on this one. This wire's too big. So that's off. Okay, good. So I'm going to go ahead and strip it to about there with the razor knife. They got these little razor knife things that hook onto wire and you spin them around, and they work really good because you really don't want to break any strands. But I'm just going to use this here. Now I can feel, when you get down deep enough, you can feel the wire. So you don't want to cut into the wire too much. Hopefully I won't lose any strands. If I lose a couple strands, it's not going to be that big a deal, because even though there is going to be a load on this wire, the panel itself, the wiring's not this, the wire going to the paneling on this boat originally was not that thick as this, so I think this is more than enough wire here to be safe. Okay, so I didn't lose any strands. And so this is tinned copper. So you got to be careful, because you can see the it's silver wire, and you got to know what you're buying. If you always want to use copper wire. There's aluminum wire that they use. You know, people can use. Don't ever use aluminum wire. It's a fire hazard, and you can get fooled because aluminum wire and tinned copper wire. And what I mean by tinned is it's the wire itself, it's copper, and copper is copper color. But the reason this is silver is it's been tinned. So it's run through a bath of tin. So it's like solder from for soldering wire together. So what that does is it keeps it from corroding. So this is marine grade wire, and tin wire is marine grade. Tin copper wire is marine grade wire. And so now I'm gonna go ahead and I need some shrink tube. So basically on boats, when you do electrical, usually on DC, you'll see like a lot of electronic stuff will have a red wire and a black wire, and that's normal. But because on a boat, or even mainly on boats and RVs and stuff like that, you have an AC system, and it's a high voltage system, just like your house electrical system. And then you have like a 12 volt or 24 volt DC system. Well, it's better to use yellow wire instead of black wire on DC, and the reason for that is because sometimes when boats are wired, the problem with that, the reason why you want to use yellow is because when somebody wires a boat, this could even be at the manufacturer, they may run a bunch of wires in a bundle throughout the boat, and they may combine DC and AC together, and you might be working on it. You might be adding something that's to the 12 volt system, and you grab the AC black wire instead of the DC black wire, and you cut into that AC black wire, and if the power's on, you can get killed. So that's the reason why you really want to use yellow instead of black on DC side of the electrical system. So any future wiring, if I can get yellow wire, I will probably do that. So I'm going to go ahead and crimp this. Now I'm going to see if my hydraulic crimping tool has a bit this size for this. Looks like it does. Make sure the wire's in all the way. Okay, here we go. Okay, that's as far as it's going to go. And that's not going to come loose. It's definitely on there tight. And then, so I'm not really losing any wires here. Now I'm going to go ahead, put some heat shrink tubing on it. Oh, it's marine grade too. Oh, that's really good. Okay, so that looks good. And the shrink tube that I just used is marine grade, which means it's got glue in it. So when you heat it up, glue is actually oozing out around the outer end of the shrink tube. So that keeps it watertight. Now, whenever you're wiring anything, if you don't know what you're doing, get somebody that does, and don't really do it yourself. I know this is going to be safe because this wire is bigger diameter than the original wire that this boat came with, and this boat was built to Lloyd's of London specifications, so I know it's safe. So I'm very confident that this is going to be safe, but you really need to know what you're doing when you're doing electrical stuff. Even 12 volt stuff, especially with these lithium batteries that I have, they discharge a very high amount of current extremely fast. And matter of fact, one of those there's 20 of those cells in my battery bank. And if you take just one of those cells, it's only 3.2 volts nominal DC. I mean, you could stick your tongue on it and it wouldn't shock you. But if you stuck a wrench across there and shorted out the terminals, that wrench would turn bright red within seconds, and it'd literally melt a metal wrench. because that's how much current it can dump out. And the voltage, the reason why you wouldn't get shocked is because the voltage is really too low to shock you. 12 volts is really safe. 24 volts is safe. Once you get over 30 volts a DC, it can start getting dangerous. And you get up to like 48 volts, it can be lethal. Even over 30, around 30 can be lethal. So you really need to know what you're doing. And so at any rate, so that's this end, and I'm going to go ahead and figure out what size, how long I need this. This is probably going to be good enough. I like a little extra long than not long enough, because then I have to redo it, and I don't have any more wire like this. So I'm going to go and check to see what I got here. Okay, so that worked out good, so I'm just going to do the same thing to the other end. So this is all done. So got too much stuff out here. I can't see what I'm doing. Ah, there it is. Okay. Okay, so I got the ground wire done. Got the ends on. I got the one that's going to go from the DC switch. This is going to go, so the battery goes to the DC switch, and then from the DC switch it's going to go through this wire to the battery protect, and the ground wire will connect to the negative side, and this will power the battery protect. And then there's one more wire, and that's the wire that's going to go from the battery protect to the panel, the DC panel. And I just got to unhook it from the switch, and I think the terminal size is going to fit, so I won't have to do any changing of lug size. Hopefully when I remove it and look at it, I'll be able to tell. And so hopefully the wiring is all done now, so all I got to do is hook it up, program it, and it should be good to go. This is the wire yesterday, the ground wire, and before I program it, I'm going to go ahead and remove this jumper here. It's a remote jumper because I don't need it in there. So I'll pull this out, set it aside. It'll go back in when I'm done. And the next thing I'm going to do is I'm going to go ahead and disconnect the cable from the switch that goes to the panel. And I want to see if it's going to fit on here. Now I'm not going to hook it up yet, this one cable, because you don't want to hook it up until after you get it programmed. That's what it says in the manual, and they don't explain why you want to do that. But I've come across a few people that said that when this thing shuts down at low voltage, that's what it does. When the voltage on the battery gets too low, it'll shut down the battery, the system, so it won't drain on the battery any farther and damage your battery. And then, like if you have solar panels, let's say, and it's been cloudy, and your solar charging system isn't working well because it's been cloudy and not getting enough sunlight on the panels, then your battery, you'll start using more of your battery capacity up. And then if you get down to the point where this shuts down to protect the battery, then of course now there's no draw on the system, on the battery or anything, but the solar panels will still be charging. In like the next day, the sun might come out and the panels start charging again. As the voltage goes up to a certain point, and you can program it for different settings for this, then this will open back up and your system will start working again. So what I'm setting this at, I'm going to program it here in a minute, and I'll explain what setting I'm going to use and why. So first thing I'm going to do is I'm going to remove this one cable from the switch and see if it's going to fit onto that terminal. Now, let's see what I got. It feels like I got some washers on here and stuff, so I don't want to drop them. So I pull this off carefully. Okay, so got a couple of washers on there. This cable is loose, and it looks like it's definitely going to fit. Now you'll notice that I have a wire, a little white wire wrapped around this red wire. And the reason for that is on the panel, on the DC side of the panel, actually the AC and DC sides both have separate displays. And so they're LED numeric displays, and I can flip a switch on my panel to check the voltage on the battery. And so that's what this white wire's for. And I'm going to leave it on there so I can still do that, even though the panel voltage meter is not super accurate, but it's close enough that it will. So this is definitely going to fit. I don't see no problems here. This, where I just removed this wire from the switch, I'm going to replace it with this other wire. Get this off of here. Okay, now gotta see how this is going to work out. Now this wire, I'm going to bend it because it's going to have to be bent. And this is the wire I just made. And I'm going to go ahead, kind of get it down. I'll go under these other wires and set it on the terminal like that. And I can go ahead and bolt that down. I'm hoping this is 9/16 so I can use the same socket here. Yeah, I think. Okay, I need to flip the switch here. Yeah, I think it's going to work. Now, it'd be a good idea to use a torque wrench and torque it on with a torque wrench. And I used to have a torque wrench, but it got real old and I don't trust it, so I'm just going to do this by feel. I'm pretty good at this. I do this kind of stuff for a living, except I work on coffee brewing equipment. Okay, that's good. It ain't gonna come loose. Okay, now, you know what? I'm gonna make it look a little nicer. I'm gonna get that straighter. I like things to look nice and even if I can do so. I don't know why. It's probably all those years in drafting class in high school. That looks better. Okay, now, as long as I can get this on the switch without too much trouble. I had a feeling this cable needed to be a little bit shorter, but it'll go. I hope. I just hope I got room so I can turn the nut. Yeah, this is not a lot of room. I hope that nut will fit on here. I don't know if the nut and the socket's going to fit. Have to do this by feel. I can't really see down in here. Yeah, it is not going to want to go on, I don't think. Let's see, maybe. Ooh, it's on. It went on. All right. It's going. Hear it clicking. Okay. Just tighten it down good. Thing is because this boat has an engine, a diesel engine, when I run the engine, it creates a lot of vibration. Diesels vibrate a lot. And so things can work loose. So you really need to make sure you get stuff tightened down good. And last thing I need is this to come loose on me. Of course, if it comes loose here, it'll shut the battery down because the connection will come loose. But oh, this is great. It's going on, no problem. Okay, I just need to tighten it down good. Now this is a brass nut, so I got to be careful. I don't want to strip anything, but I want it tight. So just a little push at a time, just a little push and a little push. And I think that's definitely on tight enough. Okay, so that worked. Lucked out there. Okay, now we're gonna program it. Okay, next thing I'm gonna do, I got two wires connected to this. So one is the ground wire, that's the one in the middle. This one on the outer edge is for programming. So I'm gonna hook up the ground wire first, and the ground is over here that way. And it's hard to see, so I'm not going to put it in the view of the camera. And I'm just going to go ahead and hook it up to the ground wire. Now, the ground wire on the battery is the negative side of the battery. So on DC systems, ground and negative are the same thing. So you can hook, if it says hook to ground on the DC, not on DC now, I'm talking DC, that's the side you want to hook it to the negative side of the battery. So that's what I'm going to do now. And hopefully I measured this right. I'm sure I did. Okay, it's going to fit. Yep. Just right. Just enough. So now I'm going to plug this plug in. Get this program wire out of the way. Now I screwed the program wire in. They have little screws that hold them in here to the plug. And I didn't put it in real tight because I'm just going to pull it out because I don't think I can get to the screws. No, when this is plugged in, so I don't want to unplug it. Once I get it plugged in, it's going to stay. Okay, now I got the program wire in. Now, if this works as it should, and I don't know if you can see it on camera angle. Let's see, I get my finger. Yeah, you should be able to see it. The LED down there should light up now. So now I take this program wire and I touch it to the negative side of the battery, the ground side. And that little LED should light up, and then by touching and disconnecting this and disconnecting it from the ground side, just touching the ground side, the negative side of the battery, I can program this. So let's see what happens. Now I don't hook this other terminal up yet until it's programmed. That's what they say in the book. So I think, like I was saying earlier, the reason for that, and I'm not sure, I hate when people tell you to do something but they don't tell you why, and I'm probably guilty of that in some of my videos as well. I think it's because this, when it shuts down to do the low voltage on the battery, and then like your solar panels start charging it back up, some people are having a problem with it coming back on, and it should come back on automatically. So let me see what happens now and see if that lights up. Nope. Well, that's not good. Okay, I know why. I got to turn the battery on. So I'm going to turn the battery switch on. And there it goes. It's flashing now. It flashed blue back and forth. So now, and then it shut off. So now when I touch this, it should tell me I'm in the first mode, and that's the mode I want to be in. Oh, I just see a problem. I got this in the wrong frickin' hole. Okay. It needs to be in this other one. So somehow, when I put this in, I had it backwards. I'm going to have to pull that plug out and do this, and I hope I didn't damage anything. I don't think I did, but... because I'm in the alarm. It was in the alarm position, and it was plugged into the alarm connector, and I need to be programmed to the program connector. So I'm going to have to pull that out. I'm going to have to pull the plug out. I'm going to shut the battery off, and I'm going to go ahead and pull this out and hook this back in the right side. It's actually on the left side, but in the right position. So I need to go in this other one. It's always something. So it needs to go into this one here. So it goes this way, it needs to go into this one. It's upside down and backwards, and that's probably why I got it wrong. Okay, and I'm going to tighten it down. I want it in relatively tight, but not too tight, so I can just pull it out. Okay, now it should be in the right spot. Let's plug it back in. Ain't this fun? It's fun when it works. Otherwise, it ain't no fun. Okay. Okay, it's all plugged back in good. Make sure it's good and tight. Okay, that looks like it's all the way in. Double check it one more time. Yeah. Okay, now I'm in the right spot. I'm in the right hole this time. Okay, now power it back on. Turn the battery on, and there it goes. It's showing that it's on. Okay, now the LED was flashing blue, and now it's stopped. Now we should get a 0 and A. Let's see what happens. There's 0, and then it says A, and that's the mode I want it in. So that's how you program it. Now, you can hold this down, and it'll go 0, then it'll go 1. Now, if I let go, now it's programmed to A1. And so you can scroll through. So there's 9 numbers here. 0, actually 10. 0, I think, goes from 0 to 9. 2, 3, 4, 5, 6, 7, 8, 9. Now, each one of those is a different setting. And so what it'll do is it'll make this shut down at a certain voltage and restart at a certain voltage. And so I'm going to go back, and there's also A, B, C, D, E, I think, and those are different modes. Now, A is just the general mode that you're going to probably use this in every system. It's always going to be on A. There is like a C mode, and that's for lithium ion batteries, which this is a lithium ion. It's a lithium iron phosphate battery. But I don't have a balancing circuit built in. It is actually, there is a balancer on my other little monitor that I showed earlier, but it's not a BMS, a battery management system. So I'm not going to use C. I'm going to only use A. So I'm going to go ahead and reprogram this to where it needs to go. So I want 0 and A. And there it is, 0 and A. And that's good. So now I can go ahead and hook up the other. I'm going to test it again. Now, just to test it again, all I got to do is just touch it to the negative terminal just for a second until it lights up, and then release it, and it'll flash the number, the A and the number a couple times just to reconfirm that you can see it's in that mode. I'm going to do it one more time. Just momentarily touch it. Now let it go. 0 A, 0 A. Good. So now it's programmed. So now I'm going to go ahead and I'm just going to pull this program wire out. Should be able to just yank it out, and there. So now that's set. And now I'm going to go ahead and I'm going to put the other cable on. And then I'll put the alarm or the remote jumper back in, and I should be set. Let's see what happens. Okay, there's a manual that comes with this, and it has a chart for all the different settings. And of course, I lost the damn thing. I've had this thing for years. I haven't hooked it up yet. And so usually I kept this in a box, and I kept it. Usually I keep all the paperwork together with stuff, but when I opened up the box, the manual was gone. But of course you can find it online, and that's what I did. So there's a jumper here. So now hopefully this will come on. Yes, it's working. So that was the problem there. And it says 13.06 volts. It's not real accurate. This is on my panel. So now everything should work. Let me see what happened there. I just saw that light flash. Yeah, okay, it's got a little LED that's flashing. So let me look at it again and wait a second. Oh yeah, it's a little blue round LED at the bottom of the number. I don't know if you can see it, and it's flashing about every couple seconds. And it's just to let you know that it's on and working, so it doesn't use up very much energy. Okay, so everything's set. Now let's see if the lights and stuff come on. So before I move this camera, I want to explain what I set this out. So, and I want to explain what 0 and A stands for. So, like I said, A, B, C, D, those are for different setups. And A is like just a general setup, which is mostly what you're going to use. The other ones are for different things. I think one of them might be for, I'm not sure. I didn't really go through all of them. It kind of says what they are, but it wasn't anything that I needed to be concerned with because I wasn't going to use them. But at any rate, so there's A, B, C, D. I told you C was for lithium batteries. If you have a BMS, a battery management system on your battery, then you'll want to set it to C. I do not have a BMS on this. I probably should have one on there, but this is pretty safe now. I got it to where I'm really confident that I'm not going to, when I charge it, I'm very careful because I'm using shore power. Now, when I get my solar panels in, I may go ahead and put a BMS on there. And actually, I do have one. It's a really cool unit. It's pretty complex. It's not for like beginners. It's this guy actually builds them in his garage, I believe, in Canada. And when you buy this system from him, you're actually part of the design team because it's open source, and so the software is open source and the hardware is open source. So things can be changed, and he's fine with that. And if you can make an improvement on his product, he's real happy with that. So so that's the unit I got, and that will be my battery management system, and so that'll be in a future video. And so A is just like a general setting. That's what the A stands for. And 0 is the first setting. And it's not the lowest setting. Setting 2 and setting 3 actually will drain the battery down farther. But I don't want to go down too far because you can damage the battery. So I'm set with the 0 setting. What it is the under voltage shutdown is at 10.5 volts on the whole battery. So it's a 12 volt battery. When the 12 volt battery goes down to 10.5 volts, it's going to shut down. Now each individual cell, and in this case I got supercells, which are 5 cells hooked in parallel, which makes one big cell, and there's 4 of those. So one supercell, once it shuts down at 10.5 volts, the supercells will be drained down to 2.625. You don't want to go below 2.5. Now there's 2 settings here. There's the next setting, which is setting 1, will take the cell, it'll drain down to 2.5. And that's really that's getting a little scary, because if your cells aren't balanced properly, or they're all the same, it's called bottom balancing is what you want to do in this situation. If one of the cells goes lower than that, because it'll say 10.5 volts on the entire system, it's not reading every cell. So this does not read all the cells. It just reads the entire battery as 12 volts. And so if any one cell is lower than the rest of the cells, it can get damaged. So I think that the 2.625 is safe. 2.5 is as low as you want to go. You don't want to ever go below that. And you can set it on setting 1 and get the cells to go down to 2.5. And the reason for that is that the lower you drain it, then when you recycle it, you got more battery capacity, a little bit more, but it's not really enough to risk damaging. I can set it to where it's actually higher, but But this setting to me, I think, is good. If I go down to 10 volts instead of 10.5, then the cells will drain down to 2.5 volts, which I was saying you don't want to go below that. So that's kind of risky. If the setting 2 will bring the total battery voltage down to 9.5 before it shuts down, and that brings your cell down to individual cells down to 2.375, and that's below 2.5. 2.3 is below 2.5, so I definitely don't want that. So I think that 0 and A was the setting to use. So now that's the whole reason behind that. And so it's actually pretty simple. And Victron makes really good stuff. Now, there's another thing, is I could have programmed this with my smartphone because it also has Bluetooth. Now, I didn't bother with that because I did put the app on my phone, but I didn't bother with it because this is the only piece of Bluetooth in here as far as my electrical system. And once it's set, it's set. I don't need to change it or worry about it. So there was no really need to do it. So I decided to do it this way. It's a simple way, and I can show you how to do it this way. And now if I had, like a lot of people have all Victron, they have Victron battery chargers, they have Victron solar chargers, they have Victron smart batteries, they have Victron BMSs, they have Victron inverters, and they all have Bluetooth, and you can control everything with your phone, which is really cool. But my system is totally custom. I built it myself, so I don't have all that luxury, which is no big deal because once I have everything set, it's pretty much no brains. I don't have to really worry about it. So there's not really a whole lot of need for me to be, tweaking stuff around. And like I said, once it's set, it's set. So let's see what happens now with the power. Here's the panel. And you can see all the red switches are off. The yellow ones are for the AC side, so that's on and got AC turned on. But so we're going to go ahead and I'll turn on some stuff here. Now, I was talking about I have a voltmeter here on the panel, so I'm going to turn it on. It's this switch right here on top, and it should light up. And there it says 13.05. And the thing about this voltmeter here is that when it's raining outside and stuff, it does all kinds of crazy stuff. Even though it's not getting directly wet, just moisture in the air affects it, so it's not real accurate. Now I do have this other one over here, which I showed earlier. I'll turn it on, and it's on and working. And this tells me each cell, so it monitors each supercell, and it's going to tell me how balanced they are. So those bars there show the levels. It has the voltage and the levels of each cell. So there's 4 supercells, and the overall battery is at 13.18 volts, and it's 10 millivolts out of balance. So that's the difference in how charged they are. And cell number 1 is 3.289. Cell number 2 is 3.294. Cell number 3 is 3.294. Cell number 4 is 3.299. Cell number 4 has always been the better one, and cell number 1's always kind of been lagging a little. But they're really, really close. I mean, 10 millivolts out of balance is really good. They're really, really close. So you can see they're at 3.2 volts. That's nominal for these batteries. What I'm going to do now is I'm going to go ahead and program this so the alarm goes off. So this is 2.62. So I'm going to set this at 2.63. Let's see if I can do that. I think that's good. I'll test it. I'll have to wait for these batteries to run all the way down to do that. So, but it's set for 2.68, and so we'll see what happens, but that's going to be a while before these run down because it takes a long time. When you got 10,000 watt hours of storage, this battery bank's huge, and I don't run a lot of DC stuff off of it, so eventually I'll have more stuff connected to it. like my refrigeration system. It's running on shore power right now, but I can hook it up to the battery. It is 12-volt system too. It runs on both AC and DC, my refrigeration. At any rate, that's how you program that. So now the alarm's set to go off, hopefully just before the system shuts down. This alarm will go off first. There is an alarm. You can hook an alarm up to the battery protect that we just installed, the Victron. It does have a wire connector for that, so you can have an alarm, and it can be either an LED that flashes or a buzzer, or both. Hopefully everything will work. Now let's test it out and see if the lights and stuff comes on when I turn this panel on. And you can see my voltage over here is jumping around on this damn display. That's another thing, is what happens with it is the longer it's on, the more it jumps around and acts weird. So the previous owner had this problem with it too. So I'm going to go ahead and shut this off. You can see the light is off. And now I'm going to go ahead and flip this first switch here. And when I flip it, let's see if the light comes on. And boom, and there it is. So everything's working. Another successful project well done. I always seem to luck out. I don't know why, but I do. Just something about boats. Whenever I work on them, I tend to luck out on stuff quite a bit. So that's the Victron Battery Protect 220 amp system, 12 volts or 24 volts. It works on both. And so hopefully it'll protect my battery now. I won't have to worry about it in case something happens and I forget to shut something down. I leave the boat, it gets drained down to a certain level, it'll shut down and protect my battery from over discharge. If you found this video to be helpful or entertaining, please like and subscribe.